Good evening, students. Today, in the first unit from the Computer Architecture Organization, the topic which we are going to see is addressing modes and its types in detailed way. So basically, the addressing mode specifies the different ways in which the location of the operand is specified in the instruction is referred to as addressing mode. So there are various ways to specify the memory location of the operand in the instruction. So that is called the addressing mode. There are various types of addressing mode we are going to see in detail way. First one, immediate addressing mode, direct addressing mode, indirect addressing mode, register indirect addressing, relative addressing, indexed addressing. So before proceeding to types of addressing modes, we should know the term meaning called EA, effective address. So effective address is the location of the operand which is stored in the memory. So it is specifies the location of the operand which is stored in memory. By computing this one only, we are in a position to able to proceed the calculating the memory location specified in the instruction. These are all some of the examples. So we are going to see with many examples for each category. First one, which we are going to see, is called the direct addressing mode, very first addressing mode. So here, the effective address is nothing but the address field of A. See, from the example, you can see the instruction given is add A. So add is the instruction which add two operands and the result will be stored in the destination register. So the contents of register A are added with the accumulator and the result will be stored in the accumulator. This is the meaning of this particular instruction. So from the diagram, you can able to see usually the instruction contains two things. One is opcode, operation code, followed by the operand address. So here in this example, address A is specified is given. If we are going to that particular memory address, in the memory, we are in a position to get the operand. So we can say it is a single uh, reference needed to access the operand from the memory. So no additional switches are needed to get the address. So we can say it is a limited address space. This is the type one called direct addressing mode. So second one is called the immediate addressing mode. Here, the operand, or we can say data in general, is specified explicitly in the given instruction. So the operand is explicitly specified in the instruction that is operand equal to value. Nothing but an operand, value or data. So example given is add 5. Add is the instruction. 5 is the constant value or operand. So what it will do, it will add the contents of accumulator with the uh, data value 5 and the result will be stored in the accumulator. Here, if it is already directly mentioned in the instruction itself, so there is no need to access the memory. Comparatively, it will be a faster in execution, but limited range. So the format will be opcode followed by the operand. Third addressing mode is called the indirect addressing mode. Indirect addressing mode. Here, what we will do is we will go to the particular memory location that is pointer. It is nothing but a memory address. Uh, After that, if we are reaching there, there will be another memory address to get the operand from the memory. So in this way, so we can say multiple access memory access are needed to fetch the operand address. So let us see with one example. So in the given example, opcode followed by the address of A. So that contains the memory location. If we are going there, there will be say another pointer, nothing but a memory address available for the operand to be fetched from the memory. So it will be, so if I am going again to the pointer or operand, it will be again So thereby only I can reach the operand or data. I'm in a position to access the operand. So there are two memory access are needed or multiple access are needed to fetch the operand from the memory. So comparatively, it will be a slower in execution. Here, register addressing. So the operand is held in the held in the register named in the address field. Say example EA, the format is EA equal to R, effective address equal to register. So if it is there is no memory access needed here, but it will be faster execution if you under limited address space also. So the instruction will be in smaller or we can say shorter, faster instruction execution. See, we will try to understand with one example. So opcode followed by the register address R. So the opcode followed by the register R, nothing but the register R contains the memory address. If we are if by accessing that, we will get the operand from the memory. So if the registers are limited, the performance cannot be improved. If I am having multiple registers, then only I can able to achieve the good performance. So this is the way to improve the performance in register addressing mode. So register indirect addressing mode, similar to the indirect addressing mode which you have seen in the memory, memory category. So here also it is needs two-way, two accesses are needed to get the operand address. So first one contains opcode followed by the register address. If I am reaching the register address R, there will be another memory address, that is nothing but a pointer available. So if I am going there, if I am moving to that particular location, there will be operand available. So there are two steps are needed, two memory references are needed to access the operand. This is the register indirect addressing mode. So coming to the next one is called indexed addressing mode. So indexed addressing mode will have the format called E effective address equal to displacement value, nothing but X plus contents of the register. So the address field holds two values. One is called X is nothing but offset value or constant value. Displacement value. There are the three names we can call it: offset, displacement value, or constant value. So R is nothing but a register. If you are mentioning it that in the within a square bracket, it mean for contents of the register. So register that holds the address of memory locations. So let us see with one example. So opcode the former instruction says opcode followed by register value and a constant offset value. So the register R, if I'm trying to access the register R address, it will point another memory address. So I have to add that memory address with the constant value or displacement value or offset value. If I'm adding together, so I will get another memory access address, memory location of the operand. So if I'm getting that address, I'm in a position to get the operand from the memory. So in this way, indexed addressing mode works. So relative addressing mode. So it is also similar to indexed addressing mode. Instead of the difference is instead of indexed addressing mode, I am using here register address. I am using the program counter, contents of the program counter. So generally you are aware that the program counter always point to the next instruction to be executed in the memory by the microprocessor. So it always specifies the address of the next instruction to be executed in the memory. So where it is used locality of reference and cache usages. So this is the way. So next one will be auto increment mode. Auto increment mode. So in auto increment mode, the address of the current memory location will be moved to the next memory location. Usually it will be 1 byte. If it is a 1 byte memory location, it will be automatically incremented to the next memory location. This is what the if I am executing one time the auto increment mode. Similarly for auto decrement mode also. So in the auto decrement mode, it will do the reverse of auto increment mode. Here, the memory location will be decremented to the previous memory location by if I am executing this instruction only one time. So it is called a EA equal to RI. So RI minus the contents of memory location will be decremented by 1 byte memory location. So this is called auto decrement mode. So these are all the examples we have seen for each type of addressing modes. There will be some problems are given in the classroom. We have solved one examples. There are another practical examples work examples we have to work it out. Thank you. Please thank you for watching the video.